In this video, we're going to go over section 1.2, which is on relations and functions. So I'll start with introducing the definition of a relation. So a relation is just a set of ordered pairs. So for example, we were given this set here, which consists of the ordered pairs 1, -2, 2, 3, and 4, 7. This is how we would write the set of ordered pairs, and then these curly braces here denote that we're looking at a set. So we have a set of these 3 ordered pairs. So in this case, the domain is going to be all of our x values. So this will be 1, 2, and 4. And it will be the set of 1, 2, and 4. And then our range will be the set of all of our y values. So -2, 3, and 7. And another way to display a relation is what's called a mapping diagram. So in this case, we would use these ovals here to represent the values in our domain and range. And then we say that f is a mapping, which will map our values from our domain to the values in our range. So 1 maps to -2, 2 maps to 3, and 4 maps to 7. All right, so a function is a relation where each value in the domain, so all of our x values, so each x value appears only once. Right? So an example of this, let's say we're given the set of ordered pairs 1, 5, 1, 7, 3, 2, and 4, 9. And let's say we are asked, is this relation a function? So just note here, our domain is going to be all of our x values, right? So we have 1, 3, and 4. And our range is all of our y values. So we have 2, 5, 7, and 9. And we do want to list them in increasing order. And just by our definition of a function, we know that this relation here is not a function because these x values are repeated. Okay? So this one is not a function. All right, let's look at another example. Let's say we're given just a graph. Now this here is a graph of what's called a parabola. This is the shape of this graph. And let's say that's all we're given and we're asked, is this a function? Well, just looking at this, what we can do is use what's called a vertical line test. So the vertical line test tells us that if we were to draw a vertical line anywhere on our graph, it can only intersect our graph once. And if that happens, then it is a function. So what I mean is, we can draw a bunch of vertical lines like this on our graph here. And if each line only intersects our graph at one point, then we do have a function. And as you can see here, we drew a bunch of vertical lines everywhere, and at no point are these vertical lines intersecting our graph at more than one point. So just by looking at this and using our vertical line test, this is a function. So just a quick example, if we were to have a circle and we wanted to figure out if this was a function, we again would use our vertical line test. So we can draw a bunch of vertical lines like this, and as you can see, zoom in, our vertical lines are intersecting our circle at 2 points. Every line will intersect our circle at 2 points, so this would not be a function. All right, and then just as a side note here, the domain for this graph is all of our possible x values. So this is going to go on forever and ever in this direction and forever and ever in this direction. So our domain is just going to be negative infinity to infinity. And then our range is going to be all of our possible y values, all of our possible outputs. And as you can see, this graph is going forever and ever in this direction and never crosses our x-axis, so it's never going to be negative. So all of our outputs are going to go from 0 all the way to positive infinity. So only positive outputs. Okay, so next we're going to look at function notation. And so we will write our y, or our output values, as f of x. So we'll use this function notation to emphasize that all of our output values are functions of x, so all of these values are dependent on what our x values are. So for example, if we had this function of x, all of the outputs, or all of our y values, aka all of our f of x values, are going to be dependent on what we put in for this x value. So if I were to make a table, just to emphasize y is equal to f of x, and I wanted to see what output values we get for 1, 2, and 3, what we can do is just plug in these values into our x value here. So first, looking at f of 1, this means we're plugging 1 into our function. We get 2 times 1 squared minus 1, and we just get 1. All right, doing the same thing, let's put that here. Now let's say we wanted to figure out what f of 2 is. We again just plug in 2 wherever we see an x. So we'll get 2 times 2 squared minus 1. So we get 2 squared, which is 4, times 2, which is 8, and then we take away 1, so that is 7. All right, now lastly, we want to figure out what f of 3 is. So again, just plugging 3 into our x value. We get 2 times 3 squared minus 1. So we get 3 squared, which is 9. Multiply that by 2, we get 18, and then take away 1, we get 17 here. All right, and something to note here, this is a function. Now remember, our definition of a function said that these x values cannot repeat. So what we mean by that is we can't plug in one x value and get 2 different answers, right? No matter what, when we plug in 1, we're always going to get 1. When we plug in 2, we're always going to get 7. When we plug in 3, we're always going to get 17. There's no repeated x values. Going back up to this example here, where we had repeated x values, if we wanted to look at this in a table form, how we did for the last example, using these ordered pairs here, we get, if we put in 1, we output 5. Put in 1 again, we output 7. 3 gets 2, and 4 gets 9. So this tells us that when we plug in 1 into whatever function we have, or this is not a function, but if we plug in 1, then we output 5 and we output 7. So the fact that we can get two different y values for the same x value tells us that this relation is not a function. And then going back to this last example, we will not get more than one y value for each of our x values, so this is a function.